The 30th of September, 2004. The waters north of Chichijima Island, Japan. A depth of 3,000 feet, which is about 914 meters. A camera is lowered, along with bait. Unmanned. Just equipment and darkness. At 9:09 a.m., an object approaches from the distance. Scientists review the footage. They measure its size. They confirm the species name. Architeuthis dux. The giant squid, alive, in its natural habitat. For the first time in history, before that day, the giant squid existed in science only as a corpse, as wounds on whale skin, as pure conjecture. After that day, every model of deep ocean predation had to be completely rewritten. This is the giant squid, and this is what its existence has changed. The giant squid lives primarily in two bodies of water. The mesopelagic zone, from 1,000 to 3,300 feet, or about 305 to 1,006 meters, and the bathypelagic zone, from 3,300 to 6,600 feet, which is about 1,006 to 2,012 meters. Some individuals have been recorded down to 6,500 feet, or about 1,981 meters. No individuals have ever been recorded near the surface while alive. You are sitting about half a mile, which is about 0.8 kilometers, above the waters where the giant squid lives. And for 365 years, science did not know exactly what was living down there. There are three reasons for that. First, technological limitations. Cameras and manned submersibles before the 2000s could not operate stably at 3,000 feet, or about 914 meters, for long enough to observe animal behavior. The equipment did not exist. The data could not be collected. Second, area. The mesopelagic and bathypelagic zones span over 231 million square miles, which is about 600 million square kilometers. That is larger than the entire landmass of Earth combined. No scientific budget is large enough to systematically survey a space of that incredible scale. Third, behavior. The giant squid does not surface when it is alive. Unlike whales or dolphins, there is no way to observe them from a ship. There is no way to detect them using standard sonar. It lives at depths where all standard observation methods fail. Below 1,000 feet, or about 305 meters, the rules change. And for 150 years, what lived there changed without anyone knowing. Before 2004, what scientists believed about deep ocean predation was this. There was no predator in the mesopelagic and bathypelagic zones large enough to systematically affect the food chain. The largest predator going down into that zone, the sperm whale, hunted small squid and medium fish. The model was built. It was accepted. It was taught. The data did not support this. In 1857, when the whaling industry was at its peak, scientists dissected the stomachs of thousands of sperm whales. They found squid beaks, which are undigested, horny structures, larger than any known squid species at that time. This data was recorded in the scientific literature. No one built a model based on it because there were no living specimens to confirm the existence of a species large enough to produce those exact beaks. In the early 20th century, scientists recorded circular scars on sperm whale skin measuring up to 2 inches, which is about 5 centimeters in diameter. They determined that these were the marks of squid suckers. The size of the scars implied a species with a sucker diameter larger than any species ever described. The data existed in the literature. The model simply did not adjust to it. From 1639 to 2004, there were at least 100 recorded cases of giant squid carcasses or body parts washing ashore worldwide. All of them were dead. All allowed for size measurements. Not a single case was enough to build a behavioral model of a living creature. 3 sources of evidence. All existed before 2004. The model did not change. What was actually recorded is this. Tsunemi Kubodera and Kyoichi Mori, 2 researchers from the National Science Museum of Japan, did not drop a camera down to 3,000 feet or about 914 meters, to find the giant squid. They were studying the predatory behavior of sperm whales. A camera with a small squid as bait was lowered to see from which direction the sperm whale would approach. At 9:09 a.m., on the 30th of September, 2004, an object approached the bait from below. It was not a sperm whale. The estimated size from the footage was 26 feet, which is about 8 meters. It approached, got caught on the hook, freed itself after 4 hours and 13 minutes, and left an 8-foot tentacle, or about 5.5 meters, on the hook as it retreated into the darkness. 556 consecutive photos. This was the first ever record of Architeuthis ducks alive in its natural habitat. The footage exists. The model does not anymore. The immediate question of the scientific community was not how big it was. The question was, if a 6-foot predator, or about an 8-meter predator, exists at 3,000 feet, which is about 914 meters, what does it eat? How much does it eat? And how many of them are there in the ocean? A giant squid of that size needs a significant amount of calories to maintain its body. The prey density at 3,000 feet, or about 914 meters, is not enough according to any existing model to feed a predator of this size if it operates like a normal predator. The proposed solution, the giant squid, has an extremely low metabolic rate, remaining almost motionless most of the time, only becoming active when prey gets close enough. What the giant squid eats daily in its natural habitat is up to this point still an estimate. It is not direct data yet. But the bigger issue is not what the giant squid eats. The issue is what eats it, and that changes absolutely everything about how we understand the sperm whale. Throughout the 20th century, over 1,000 sperm whales had their stomach contents analyzed, mostly from whaling stations in the North Atlantic and Antarctica. The results confirmed that squid is the main component in the sperm whale's diet. An adult sperm whale eats an estimated 1.1 tons, which is about 1 metric ton, of squid every day. Most of it is small squid. But giant squid beaks appear in sperm whale stomachs often enough to confirm one thing: the giant squid is not random prey, and it is not an exception. It is a systematic component in the diet of the largest predator in the ocean. This means the sperm whale is going down to 3,000 feet, or about 914 meters, into absolute darkness, to hunt a creature that can be 26 feet long, which is about 8 meters, and weigh up to 600 pounds, or about 272 kilograms. Not occasionally, regularly. To do that, the sperm whale uses echolocation. Sound clicks emitted from the spermaceti organ in its head are focused, amplified, and shot forward like a directional sound beam. The sperm whale's click reaches 230 decibels. This is the loudest sound produced by any recorded animal on Earth. At that intensity, the sound does not just detect prey at a distance. At close range, it can stun or incapacitate the prey before physical contact even happens. The Pre-2004 model described the sperm whale using echolocation to find small squid at moderate depths, making it an effective but not exceptional navigation and hunting tool. The Post-2004 model describes the sperm whale using 230 decibels to hunt a 6-foot creature, or about an 8-meter creature, at 3,000 feet, which is about 914 meters, in absolute darkness. This is on a completely different level. If the giant squid is regular prey, the sperm whale must dive deeper, for longer periods, and more frequently than the old model ever predicted. Tag tracking data from after 2004 confirmed exactly this. Sperm whales dive an average of 1,640 feet, or about 500 meters, during typical dives. But the deepest recorded dives reach 6,500 feet, which is about 1,981 meters, lasting up to 90 minutes continuously underwater. Before the giant squid was confirmed, no one had any reason to explain why the sperm whale needed to dive as deep as 6,500 500 feet, or about 1,981 meters. Now they do. The actual consequences of this are still being measured today. From 2004 to the present, the giant squid has been recorded alive in its natural habitat a total of fewer than 20 times. But global sperm whale stomach content analysis suggests that sperm whales consume huge numbers of giant squid every single year, often enough to confirm this is a systematic component in their diet. If the giant squid makes up a significant portion of the squid that sperm whales consume, the giant squid population in the ocean must be vastly larger than what the figure of 20 recorded sightings suggests. Current estimates of the global giant squid population range from tens of thousands to millions of individuals. That margin of error is simply too large to have any practical meaning. It is not a scientific estimate. It is an admission that no current method can accurately count or estimate the numbers of this species. The giant squid lives at depths that survey equipment cannot systematically cover. Remotely operated vehicle cameras operate site by site and dive by dive. 231 million square miles, which is about 600 million square kilometers, cannot be surveyed using that method in any practical time frame. The species was first recorded in 2004. 20 years later, its true numbers in the ocean remain a complete unknown. As of this recording, the file remains open. From 1639 to 2004, a period of 365 years, science only had corpses, beaks in whale stomachs, and scars on skin. Not a single piece of live footage. After 20 years of research since the first footage, the true number of giant squid in the ocean has still not been determined by any validated method. File under Bathypelagic Zone, currently under study. Next file, Why Evolution Keeps Reinventing Bioluminescence in Complete Darkness.